Hello, good evening everyone. We'll start the class in 5 minutes. In case if somebody have any doubts in lecture 1 to 10 or week 1 to 10, you can ask now, or you can just type your question in chat box also. Good evening, everyone. I'm Shafali Agarwal, and this is our 11th TE session on the topic of advanced concrete technology. Before we start the class, if anybody have any doubts in previous lectures or anything, you can ask now. You can put your question in chat box also. Anybody? Okay, in that case, we will start the session for today. So, we are at the last topic of our course. As of now, we will start the durability in this week, and half of the part will be done in this week and half part will be done in the next week class. So, and little overview what exactly does a durability means. So when we are talking about our concrete, it is the durability is defined as the ability to resist weathering action, chemical attack, abrasion, or any other processes of deterioration. So mainly, if we talk about our concrete system, we focuses mostly on the mechanical strength of our concrete system. However, other than mechanical strength, the other part of our concrete which is affected by deterioration due to some chemical actions or any external attack instead of loading are called will come under durability problems. So durable concrete will retain its original form, quality and serviceability when exposed to its environment. However, if we are having non-durable concrete, it will deteriorate and can cause serious deterioration issues. So main issues in concrete system is firstly corrosion of rebars, which can also cause the strength issues. When corrosion will start, your tensile strength of your steel will decrease and can cause some structural issues. Then is chemical attacks. So chemical attacks can be due to soil, from water, from air, any type of chemical attack due to the various kind of chemicals present in the environment. And lastly, ASR or DEF. ASR, alkali silica reaction, we have already studied about it in previous lecture. Other is delayed adrenaline formation, that is mainly due to the sulfate attack. So these are like the chemical reaction which are happening inside the concrete due to the external environment. So if there are some external sulfates which enter into concrete, so the chemical reaction which are happening because of those external sulfates will cause delayed epithet formation and can cause further cracks and deterioration of your concrete. Other thing is multiple transport mechanism are involved and typically countered by the choice of material and a mixed design. So more porous your concrete is, more chances of durability issues will be there, because there are more chances of ingress of chemicals in that type of concrete. And other issues is if we are not checking our structure at a regular interval of time. So first and foremost type of durability issue is permeability and porosity. So if we see about permeability, so permeability is defined as the function permeability of concrete is a function of permeability of cement paste, aggregate, and ITZ, interfacial transition zone. The permeability of these components will further relate to the porosity of the concrete system. So how much permeable your concrete is means how your pore structure will define your permeability, and in combined it will define the porosity of your concrete system. They are not directly interconnected. However, the interconnectivity of pores is generally responsible for high permeability. So in case your pores are interconnected to each other, let's say some chemical attack is happening from this direction, it will be easy to make a crack in your concrete system if your pores are interconnected. However, if your pores are not interconnected, once you have any chemical entering into your concrete system, there are chances that it will stay by at this point only, and it won't deteriorate. It will deteriorate only this part of concrete, and it won't attack your complete concrete system and can prevent major structure issues. However, if your pores are interconnected, there are chances of cracks forming. So what are the main parameters which we consider when we are testing our permeability or porosity? First thing we calculate is the threshold pore size. So how it is calculate, and other thing is critical pore size. So there are two type of pore sizes we are calculating, threshold and critical pore size. So mainly these two things are calculating using MIP test or TGA. Many things are done. So in MIP what we are doing, it is mercury infusion porosity. So you are inducing with pressure mercury into the uh, into your concrete system, and you will calculate the permeable pore volume percentage. So at one point where your permeable pore volume become constant, that is called as your threshold pore size. So below that pore size, so that means your what say your concrete system doesn't have pore diameter less than 0.10 micrometer. Okay, and uh, other thing is when differential intrusion volume. So it is a you won't get it directly from MIP. That is calculated using dV by d log d. So d means diameter of pores. Using these things differential equation of this thing only, you will get a peak. So wherever you are getting a peak, that will be your critical pore size. That means in your concrete system maximum pores are of this particular size of pores. Okay, other thing is what are the different factors which are affecting this pore size of your or pore structure of your concrete system is, firstly it is the water binder ratio. So you can clearly see here in the in a higher water binder ratio, like let's say 0.5 water cement ratio, your pore size is bigger. You have a bigger pore size. As your concrete gets compacted, you have 0.3 water cement ratio, your pore size is decreased, critical pore size is decreased. Same way in this case, it is the effect of curing. So more you cure your concrete, more will be your denser pore structure. So if you see here, in 3 days of concreting, your permeable pore volume is starting from 30%, but however at 28 days it's starting at 15%. So higher the curing, higher is the densification of your pores, and will reduce the threshold pore size. Now other thing is how permeability and porosity are related to each other is, you can get they are related to each other using the Cosny equation, where you have K as coefficient of permeability, eta is porosity. So it's a little bit wrong, it is eta cube. So eta is defined as porosity, and S in this case is volume specific surface area of the particles, and Kk is the Cosny constant. So further you might have studied how we are calculating the Cosny constant and what are the different equation. So to calculate Cosny constant, you need to know the tortuosity, and further with different type of shape, for different type of shape of pores we have different shape factor. It is already calculated using this equation. So if we give an overview of durability, if this is your let's say cross section area of any column or any beam, your you have two concrete system in this case. First you have core concrete, or let's say hard concrete, that is inside your rebars, and then you have a small outer area of your rebar which is called as cover concrete. So your hard concrete mainly is affected by your strength properties, or your strength properties will affect your hard concrete properties, and your durability properties will affect your cover concrete area, or your cover concrete will affect your durability issue. So let's take an example of corrosion. In that case, if you are not providing a proper cover, what will happen? Your rebars will be exposed to the environment, and there are chances of early corrosion. But if you have a proper cover concrete and let's say it is not much porous, in that case what will happen, your ingress of chlorides will be much slower as compared to the other case. So your cover concrete will affect your durability properties. So in this case, if we see in a reinforced concrete structure, so here it is showing this is your rebar and this is the part of your cover concrete. So this is your outer, sorry, this is your outer part, and if it is a poor quality surface, then what will happen, surface will dry easily and aggressive agents like chlorides, carbon dioxide, water will easily penetrate through the concrete and your rebar will get corroded. However, if it is a good quality of concrete, what will happen, your this cover concrete, it will prevent the ingress of these kind of chlorides or other aggressive things to enter into the concrete system. So if we talk about durability, we are dividing into two parts. Firstly, our concrete system, let's say this concrete system. Secondly, our environment, outside environment. How we can control our durability in concrete system? One thing is using good quality of materials, which will be affected by type of binder, content, aggregates, admixture, and using good mix design. Other thing is the process of concreting. So when you are mixing, transporting, compaction, curing, temperature, how your workmanship, all these things will affect your concrete system. Environment you can't control. However, in environment again you have two type of environment, physical and chemical. In physical, what are the main durability issue? It is the abrasion, erosion, cavitation, freeze and thaw. And when we talk about chemical issues, then it can be dissolution, leaching, expansion, alteration. So when we are talking about concrete system, we have different type of specification which are issued. However, when it comes to the environment, we can't control that part, so we should concentrate on a concrete system more. So these are the various Indian codes and specification for different type of concrete design, and most commonly used is IS 456. Everyone know about this. However, these are the different disadvantages of few of these codes. So if we talk about IS 456, it is only talking about strength of the concrete system. It is nowhere talking about what are the durability factors which need to be considered while constructing any concrete system. Also, all the acceptance criteria in this IS 456 is based on strength only. Second thing is IRC, Indian Railway Standard, Indian road bridge concretes. In this, they are talking about durability things. They are talking about RCPT test. However, the limiting value of RCPT is not provided, and again the problem with RCPT is that it is not valid for all type of concrete. Let's say if we have steel fibers in our concrete system, in that case you can't use RCPT as a determining factor, because it will, any idea why we can't use fiber reinforced concrete in RCPT? Okay, when we will read about RCPT, that time we will cover that part. Other are metro specification. Again, in metro specification there is no provision for the limiting values and what is the link to the actual performances. So this give us the conclusion that there is a need to have specific guidelines and specifications for construction project in India regarding durability, and also exposure classes which we are currently using like low, severe and all. It should be more relevant towards the durability things, not only towards the strength mechanism. So how to approach for durability design? Two type of approaches we have: prescriptive approach and performance approach. In prescriptive approach, first thing is avoidance of deterioration. By using inert materials or giving coating to your concrete system, you can avoid the interaction of your concrete system with the outer environment. Other thing is deemed to satisfy approach. That means prescriptive requirements on materials and present different type of codes and give good provisions. So in prescriptive, what we can have curing duration and method. What is the cement content used, binder time, maximum water cement ratio. All these factors will come under prescriptive approach. Then come the performance approach. Now you have already constructed your concrete, or you are about to your material is fixed. So what can be the performance approach in this case? First thing is what using different type of testing methods in your laboratory and ranking your concrete quality based on those tests and other factors. Other thing is using uh, modeling methods, like using service life modeling or verification using different old field data. So in performance, what will come? Your compressive strength, tensile strength, your cover depth, shrinkage, permeability, and all other tests which we will be reading in our further lectures. So if we talk about chemical attack, mainly we have 6 type of transport mechanism in concrete. And let's say what are those 6 types? Diffusion, migration, permeability, sorption, convection, and quick action. So what is the difference between this 6 type of mechanism is? So if we talk about first diffusion means flow of your ions under concentration gradient. So if we, let's say if you have more ions at one end and less ions at other end, because of concentration gradient, means more concentration here, less concentration here, what will happen? Your ions will start moving toward the lower concentration, and with time it will be almost equal. So that is a diffusion mechanism. So if we talk about in our lab system or in our lab environment, how we are calculating a diffusion thing, we have a test, say bulk diffusion test, which is given by ASTM code ASTM C1556. In this test, what we are doing, if let's say we have this type of concrete sample, we will expose it to the chloride solution, allowing chloride solution to penetrate only from the one end of your concrete system. And then after a particular time period, we will take it out, and then we will collect powder from different depths of your concrete system, and then we'll get a chloride profile. So initially your chloride content will be high, then it will be lower. So if I put it here, it will be like in this case. So you will have more chloride content in the top layer and very less chloride content in your lower layer. So from that graph you can further use a equation and calculate your diffusion coefficient value. Second type of test is accelerated carbonation test. So if we talk about diffusion coefficient, in this case we are exposing our concrete system to chloride solution. In carbonation we are exposing our concrete system to carbon dioxide. Okay, so this is an it can be naturally or accelerated also. In accelerated we have carbonation test chamber, where we are forcing a particular amount of CO2 into the chamber, and after a particular time we will break open the specimen, spray phenolphthalein in it or over it, and see the carbonation depth. So wherever your pH is less than 9 or equal to 9, in that case your phenolphthalein will give no color. However, at higher pH it will give pink color. So from here you can calculate your carbonation depth. Okay, so other tests are permeation. So permeation means permeability, let's say. So how different ions are penetrating through your concrete system through pores and all. So first thing is the water permeability. How water penetrate through the concrete system, that can be done naturally as well as it can be done forcefully using this test method. So in this test method, again we are forcing water into the concrete system from one surface, and then we will break it open and see how much water is penetrated through our concrete system. And So this is one type of permeability, water permeability. Then we can have gas permeability. So again, similar type of test is performed. In that case, instead of water, you are forcing air to go into the concrete system. So this is a small mechanism of how your test is being performed. Measuring gas permeability, and one of that gas permeability method is your oxygen permeability test. In this case, you are forcing oxygen gas to penetrate through your concrete system at a particular pressure, and in this case again you will get the values of your pressure and oxygen value, and then you can get the how much oxygen is penetrated through your concrete system, and your OPI value. You will get an OPI value. It will determine if your concrete system is of good grade or no, not a good grade. Other test is sorptivity test. So as of now, what we are doing, if this is a concrete system, we are forcing everything to go in the direction of gravity, right? We are let it be water, oxygen, or let's say chlorides in diffusion coefficient. In sorptivity test, we are exposing our concrete system to water from bottom, and we are seeing how water is entering into the concrete system through capillary action. So that is a sorptivity test. Okay, so other type of test, these are the chemical type of test. Other one of the non-destructive test which we are doing on the concrete system is Venner 4-prop resistivity test. In this case, we have a Venner 4-prop which have where outer props will have current applied, and from the inner two props we will measure the potential value. So from your from this thing you will get your resistivity value of your concrete system. So higher the resistive concrete means there are low chances of any ions to penetrate through it. So higher resistivity means a good quality of concrete. Other few tests are like we have rapid chloride permeability test. In that we are applying voltage, and in one cell we have sodium chloride, in other cell we have sodium hydroxide. So your chlorides will penetrate from one end to another under the applied voltage, and we will measure the coulombs amount of charge passed through the system. And similarly we have RCMT test, accelerated chloride migration test. In this case we are keeping our concrete system tilted, and we are forcing the chlorides to enter from bottom instead of from one end to another end. We are forcing it to enter through bottom, and same way we are getting the similar value. After the test, what we are doing, we will split open our concrete system, and we will spray AgNO3 silver nitrate over the concrete surface. Like we have phenolphthalein test for the carbonation, same way we have silver nitrate test for our chloride testing. So if one minute, if this is your splitted concrete and you will get something like this area will be whitish or let's say silverish. So this means this part is there are chlorides present in this part of your concrete system. So this will give you depth of chloride penetrated through your concrete system. Okay, other test is your chloride conductivity test. So in chloride conductivity test, it is almost similar to your let's say when a 4-prop. In this we are getting the bulk conductivity of your system. Instead of calculating your surface resistivity, we are calculating the bulk resistivity by applying in one end and other end, and then we are calculating the conductivity of your system. So those are the different type of tests which we can do to check the durability of our concrete system. Other thing is, what are the different type of chemical attacks which can happen on the concrete system. Main type of chemical attacks are sulfate attack, acid attack, chloride attack, carbonation. So carbonation is clear to you guys? Like when your carbonation CO2 reacts with calcium hydroxide is forming calcium carbonate, which will reduce the pH of your concrete system, causing corrosion. Chloride attack, again chlorides diffuses through the system, and then what they are doing, they are converting Fe2, they are converting your iron oxides to iron chloride FeCl3, which is a corrosion product causing corrosion issue. Acid attack, if we have acid in our concrete, if acid reacts with the concrete system, what will happen? It will react with your CSH gel and will cause a deterioration in your concrete properties. And last is sulfate attack. In sulfate attack, what is happening? Your sulfates, when your sulfate reacts with your concrete system, it is forming more ettringite. So this more ettringite, what will happen? They are like needle like structure, right? So they will need more space. They will push the concrete and will cause cracks in the concrete system. So we have two type of sulfate attack: external sulfate attack and internal sulfate attack. So in both cases, the common chemicals which causes the sulfate attack are sodium sulfate, magnesium sulfate, calcium sulfate, or ferric sulfates. So in let's say in groundwater, when our concrete is in contact with soil mainly, these type of attacks are very much common. So if you see here, expansion associated with gypsum and aggregate formation lead to cracking, and which will further lead to loss of strength and structural integrity due to loss of cementitious structure. So these are two type of sulfate attack because of sodium. These are the various things which is happening when sodium sulfate attack, and this is the step which is happening when magnesium sulfate attack into our concrete system. So further things about different type of chemical attack will be studied in week 12. So this is about week 11. If you guys have any doubt, you can ask, otherwise we will see few questions for this week. You can put your question in chat box also if you want. Just give me 1 minute. You can, in case you have any question, you can just put your question in chat box. Okay, in case there are no questions, we will see some problem solving questions for this week. First question is straight true or false. Mentioning the water sorptivity is an example of prescriptive specification. True or false?
False.
False.
Correct. So it is not uh, prescriptive specification. It is mostly which type of specification then? What is
Performance.
performance? Correct. Next question is both the paste and aggregate may expand during alkali silica reaction, corrosion, freezing, or sulfidification.
C. Freezing.
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 A.
A. Alkali silica reaction. Anybody else who think
A.
A? Okay.
A.
So in
C. C.
C. Yeah. So correct answer is actually C. Why? Because in alkali silica reaction, where is your reaction happening? It is happening actually at the interface of your aggregate and let's say if this is your aggregate, it will happen at the interface of this point. So in this case only your uh, paste part is being expanded, not your aggregate part. So what we are asking, we are asking when your both paste and aggregates are expanded. So in freezing and thawing, what is happening? First thing, there are pores in your paste which will store water, freeze and can expand. Other thing is, in aggregate itself you have different pores in your aggregates where there are chances of water being stored and freezing and causing cracks in your aggregate system. So when we are talking about both paste and aggregates, it will mainly happen in freezing and thawing system. Okay. Okay. So next question is, the pore size obtained through MIP that indicates maximum volume intrusion is threshold pore size, critical pore size or differential pore volume.
A.
A.
Correct. Okay, indicate maximum volume intrusion. It's E. Wait. MIP that indicates maximum. Okay, so uh, in this case we are asking the pore size which indicates the maximum volume intrusion, that will give us the critical pore size. In case of threshold pore size, the graph is like this, right? So that threshold pore size is not giving us about not telling us about the volume intrusion. It is that graph was between, what was that on the y-axis, in case you remember, it is mainly permeable volume, right? So maximum volume was actually at this point, not at the threshold point. So when we are talking about maximum volume intrusion, it is being given as the critical pore size. Threshold pore size, it is at this point where you have a constant volume intrusion, after which you have constant volume intrusion, that is your threshold pore size. Okay.
Okay.
Okay, next question is, consider the Cozzani equation connecting porosity and permeability. The S for the sphere of a sphere for a sphere of radius r is 3r, 3 by r, 1.5r or 4 by 3r.
Uh, D.
4 by 3r. Okay. So what does S means in this case? S is equal to surface area per unit volume. Okay. And if we are oh sorry, if we are talking about in a sphere, so what is the surface area of sphere? 4, sorry, that is volume is 4 by 3 pi r cube, and your surface area of sphere is 4 pi r square. So dividing these two things, you will get it as 3 by r. So the answer will be B, 4 3 by r. Sorry, 3 by r. Is it clear?
Yes.
Okay. Dash gives opportunity to use SCM and innovative additives in concrete mix design. Prescriptive specification or performance based specification?
A.
A. Correct. So before mix design, whatever we are deciding will come under prescriptive. So it will be A actually. Will come under prescriptive specification. A concrete specimen is kept under water for an extended period of time such that the pores are filled with water. Dash diffusion is likely to happen in this concrete, gaseous or ionic?
Ionic.
B.
Correct. Answer will be B, ionic. Fick's first law of diffusion is applicable to concrete specimens. True or false?
False.
False. Correct. So if we talk about Fick's first law and second law, first law is mainly in the case of steady state and second law will come under the non-steady state. So when we are talking about our concrete specimen, it will never be in a steady state system. It is always a non-steady state system. Therefore, it is not applicable. First law is not applicable to the concrete system. The diffusion coefficient used in the calculations concerning concrete specimen is true diffusion coefficient or apparent diffusion coefficient?
B.
B. Correct.
B.
Correct. So in case of our concrete specimen which are lab prepared, whatever we are calculating as diffusion coefficient will always be considered as apparent diffusion coefficient. The relationship of carbonation depth and time in an accelerated carbonation test setup is linear, horizontal, quadratic or linear initially and then parallel to depth axis.
B.
B. It's actually quadratic in nature. So I will show you in the next question how it will be. Carbonation rate is critical to model the concrete and understanding the service life of concrete. It is the slope of dash graph where d is the depth of penetration and t is the time. D versus t square, d square versus t, d versus under root t.
D versus under root T.
Correct.
D.
So usually the slope here will give us the rate, corrosion rate, and this will be a graph between d by under root t. So that's why this will be your d versus under root t. So sir might have actually taught you in the class how we are getting the corrosion rate, carbonation rate, sorry. Choose the method which can be used to ensure better penetration of water into concrete. Increasing the surface tension of water, boiling the water, keeping water and concrete under vacuum, all of the above. So if you want to penetrate water into the concrete,
B.
B, boiling the water.
B.
Any other option do you think which is correct? So other way to ensure penetration of water into concrete is keeping water and concrete under vacuum. So in lab studies what we usually do is we will keep our concrete in vacuum, then we will purge water into the system, into our desiccator system, vacuum system. In that way your water will penetrate into your concrete system very quickly. So answer will be B and C. Choose the correct statement corresponding to Venner-Fortrop resistivity test. Current is applied between inner electrodes and voltage is measured across outer electrodes. Current is applied between outer electrode and voltage is measured across inner. Voltage is applied between inner and current measured across outer. Voltage is applied between outer and current is measured across inner. From this graph, one thing is clear that
B.
yeah, current is in outer electrode and voltage is in inner. And in Venner 4 protest, what we are doing? We are measuring the voltage and applying the current. So B is correct option. Next question is, the conductivity obtained by the RCPT test of geopolymer concrete is dash regular than OPC concrete. Justify. Lesser than, more than, as same as that of OPC. Any idea?
Lesser than.
Lesser than, okay. Anybody else who think it will be more or same?
C.
See,
C.
it will be actually more than your OPC system. Why? Because in geopolymer concrete, what will happen? Your fibers will it will make a path for charge to pass from one end to another end, and in that case your conductivity will be higher or your resistivity will be lower. So conductivity of geopolymer concrete will always be more than that of OPC concrete. Therefore, in initial slide we talked about RCPT test and told that it cannot be used for all type of concrete. So this is one of those example where maybe geopolymer concrete is a good quality concrete. Even if in that case, because of the presence of these fibers, your conductivity will be higher, and then you will think your concrete is not of a good grade concrete. So the next question is, the depth of chloride penetration is determined by using chemical silver chloride, silver nitrate, sodium nitrate or magnesium nitrate. So after RCPT and RCMT test, we are spraying some chemical over the concrete interface. Which is that chemical?
Silver nitrate.
B.
Correct. Silver nitrate will give us the depth of our chloride penetration. Sulfate resistant cement has lower C3A content, higher C3A content, lower C3S or higher C3S.
A.
A.
A, correct. So it should be less than 7%. Next question is, delayed ettringite formation occurs mainly due to low curing temperature, higher curing temperature, low water cement ratio or carbonation.
C.
B.
C, low water cement ratio. No, we are talking about delayed ettringite
B.
formation. Yeah,
B. B.
correct. It will be mainly due to higher curing temperature. So if your curing temperature is higher than 70 degrees Celsius, in that case there are chances of ettringite formation in your concrete system. Next question is, performance based specification are preferred because they allow flexibility and innovation, they are easier to implement, they rely only on water cement ratio, they are faster to test. Any idea?
D. D.
A. A.
A. So answer is A. See, in performance based specification we are doing various lab based test methods, and which is allowing us to have more flexibility in the system. Instead of just restricting us to a particular thing, we have more testing and give us more chances of understanding your system better. Ingress by alternating wetting and drying cycle is called wick action, migration, convection or diffusion. So we talked about 5 to 6 type of mechanism. In that, if we talk about let's go step by step. Diffusion we already learned, like if there is a concentration gradient, then it is called as diffusion, right?
A. A.
A, yeah, correct.
B.
So in wick action means whenever your concrete surface is let's say if your environment, let's say it is near to the sea surface, if it is getting wet by waves, and after waves will go back, it will dry again, waves will come, it will wet. So this wet and dry cycle deterioration is causes called as wick action. Permeation differs from diffusion because it requires pressure gradient, concentration gradient, temperature gradient, or none of the above. So in diffusion we have
D.
concentration gradient, but in permeation what we have? Any idea? No, we are talking about what is there.
Formation pressure.
Pressure, correct. So in permeation mostly it is due to the pressure difference. Your ions will move from one end to another end. An RC column exposed to de-icing salts was testing by RCPT and showed 4000 coulomb. What does this indicate? Very low permeability, high chloride ion permeability, dense microstructure, poor workability. So if you talk about RCPT test, if 4000 coulomb is a very high charge passed, that means there is a higher chloride ion permeability. Okay. Next question is, a water tank wall shows leaching and white deposit. The likely cause is chloride ingress, carbonation, efflorescence, or alkali silica reaction.
C.
Yeah. So for white deposit, it is mainly because of efflorescence, which is caused due to permeability of water. So the last question is, an old RCC column is to be inspected for rebar corrosion. Which combination of tests provides the best diagnostic insight? Rebound hammer and slump test, half cell potential carbonation depth, ultrasonic pulse or fineness test, or setting time and pH measurement? For corrosion related thing, which are the tests we are doing?
B.
C, correct.
B.
So for
B.
I hope everyone know half cell potential test. It means we are calculating the potential of our rebar with respect to any reference electrode, and if your HCP value is less than minus 350 millivolt, more negative minus 3 millivolt, that means there are more chances of corrosion. Doesn't mean corrosion have initiated, that means probability of corrosion is more in that case. Carbonation depth, we have already seen, we will just spray phenolphthalein and see the carbonation depth. So for corrosion related issue, we will do HCP and carbonation depth. So that's all for this week. If anybody have any doubt, please ask. In case there are no doubts, you can leave the class also. So,
I have some one doubt in assignment week number 10, question number 10. Can you explain that?
week
If
10. Okay, 1 minute, I will check it. What is your doubt?
actually it is in full sentence, sustained loading on concrete leads to densification of CSH layer by viscoelastic process, and the strength is increased because of consolidation. The water in the dash will move to region with low stress. I have the water in in the final result. It is the correct answer is micropores.
Okay.
I have to understand this one.
Okay.
The
One
water
minute.
in
I
the
will.
micropores will move to region with low stress.
1 minute. I will just open that question. Eight, 10. It is sustained loading on concrete leads to densification of densification of CSH by the viscoelastic process, and the strength increases because of consolidation. The water in dash will move to the region with low stress. So your water in micropores or large capillary pores. So what is your doubt in that case?
Doubt is, I think it is large capillary pores, but it is correct answer is micropores.
The water in dash will move
Why?
to the region with low stress.
And
Okay,
I have
I will
read
look into it
question.
and maybe I will just check it once again. And just give me.
Okay, but in question and answer platform, you have get this answer. The water from micropores will move to region with low stress, which is larger pores. Please read the question again and try to solve. The
Okay,
explanation provided by you is correct, but the question asked was not the same.
where are you
What does
reading
it
this
mean?
thing?
The what I have read
Okay,
in
discussion
question and
forum.
answer platform.
Okay, okay, okay.
Yes, yes, discussion from I.
Srinivas, please
Still, I am
disable
not
the
getting
audio
the
and
question. Either I am not getting the question or what I.
wait. I will just go to it once.
Let's see.
Let me post this.
Or any other participant who answered the micropores can explain how it is.
The water is okay. See, first thing is when we are talking about consolidation. we have two things,
Yes.
compaction and consolidation. When we are talking about consolidation, in that case your water will move from your micropores mainly. It's capillary pores. It will be in the first process of your compaction itself. So if in this question we are particularly talking about consolidation method, so in consolidation method it will come under a micropores only. So you are correct that you are talking about only the second statement. In second statement, it is correct. When we are talking about in low stress area, it will be your capillary pores. But your large capillary pores will already be filled, or will the water will already would have moved from your large capillary pores before itself. In the process of consolidation, it is mainly because of micropores. So that is the difference. That's why micropores is the correct answer in this case.
Okay, okay. Right. Okay, ma'am. Thank you.
Any other doubt?
Actually, I have no doubt. In week number 12, assignment question,
Wait,
there is
12.
some confusion. There are two types. There may be two answer. Oh,
Which question?
question number two. The sulfate attack can be reduced by low C3A cement. Okay. The use of pozzolanic cement is beneficial for sulfate attack due to formation of in this more and next CSH and either lace or
Less than
gypsum
gypsum. Oh, okay. Yeah.
because pozzolanic cement produce more CSH also, and if we put less, then
Yeah, but
again C
your
in
more
we can put
CSH
gypsum.
will not be related to your sulfate attack. When we are talking about
Okay,
sulfate
okay,
attack,
okay,
we prefer gypsum part. That's why.
okay, okay, ma'am. Thank you, thank
Okay. Any other doubts?
you. No, ma'am. Bye, thank you.
Okay. In case there are no doubts, we'll close the class for today. Thank you everyone for joining.
Okay, thank you, ma'am.